Hi, I am Santosh Kumar Saraf. Today I am going to explain what is a sequence. Sequence, an arrangement of numbers or terms by following a specific rule or logic is called a sequence. For example, 2, 5, 8, 11, like so on is a sequence. So here each number is added with a 3. So 2 plus 3 is 5, 5 plus 3 is 8, 8 plus 3 is 11. So here the logic is adding 3 to the previous numbers. And here the next sequence, a square b, comma b square c, comma c square d. Here the logic is, first we are writing a square b, then after a b comes, so b square, and after b c comes. And here after b c comes, so c square, and after c d comes. So like that we are following a pattern, or we are following a rule. Next, here the third sequence is 1 cube, 2 cube, 3 cube, 4 cube, 5 cube, like so on. So here these are a cube of natural numbers. Okay, 1, 8, 27, 64, 125. We can write the cube of natural numbers in this way: 1, 8, 27, 64 and 125. So here you have to identify which type of sequence it is or which logic is followed here. For example, 5, 10, 15, 20, 25, 30, like so on. So this is a sequence. And here 1, 5, 9, 13, 17, 21, like so on. This is a sequence. So here in the first sequence, each number is added with 5. 5 plus 5 is 10, 10 plus 5 is 15, 15 plus 5 is 20, 20 plus 5 is 25, 25 plus 5 is 30, like so on. So this is a sequence in which each number is added with 5. And in the next sequence, 1 plus 4 is 5, 5 plus 4 is 9, 9 plus 4 is 13, 13 plus 4 is 17, 17 plus 4 is 21. So in this sequence, each number is added with 4. Okay, so starting from 1. So we can take our own sequence. For example, 2, 4, 8, 16, 32, 64. This is another sequence. Actually here the logic is powers of 2. That means 2 power 1, 2 square, 2 cube, 2 power 4, 2 power 5, 2 power 6. So this is also a sequence. Next, here if you see, minus 2 power 1, minus 2 whole square is 4, minus 2 whole cube is minus 8, minus 2 power 5 is minus 32, and minus 2 power 6 is 64. So like that we will get so many sequences. We can write our own sequence. And here minus 1 power 1, minus 1 whole square is positive 1, minus 1 whole cube is negative 1, minus 1 whole power 4 is positive 1. So like that we can write our own sequence. Okay, so in all these sequences you might have observed there is one sequence in which the difference between any two consecutive terms or consecutive numbers is same. Such sequence is called as arithmetic progression. So see here, 5 plus 5 is 10, 10 plus 5 is 15, 15 plus 5 is 20. So here the difference between any two consecutive terms is same. 10 minus 5 is 5, 15 minus 10 is 5, 20 minus 15 is 5. So here the difference between any two consecutive terms is same. Such sequence is called as arithmetic progression. Okay, so here 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 2 is 8, like so on. So here the difference between any two consecutive terms is 2. Suppose you take the next sequence, 3 plus 3 is 6, 6 plus 3 is 9, 9 plus 3 is 12, like so on. So here the difference between any two consecutive terms is 3. That means if the difference between any two consecutive terms is same, if the difference is same, then such sequence is called as arithmetic progression. Okay, so here all multiples are in AP. All multiples, like all multiples of natural numbers or all multiples of integers are in AP. Okay, so we can write our own arithmetic progression. So I am taking a number 11. So 11 plus 6. 17, 17 plus 6 23, and 23 plus 6 is 29. So here the difference between any two consecutive terms is 6. So this is called as arithmetic progression. Here in arithmetic progression, we are naming the numbers or members as the terms. So here the first number is called as first term, and the second one is called second term, third one is called third term, and like so on, 100th term and nth term. So here first term is a1, and that can be written as small a. Next a2, I am adding d to the a, so therefore a2 becomes a plus d, and I am adding one more d to a plus d, so it becomes a plus 2d, so that is a3 now. Okay, so here the difference d is difference between the second number and the first number, that is a2 minus a1, and that is also equal to a3 minus a2, and like so on. So since it is the difference of the succeeding term and the preceding term, so here the succeeding term I am taking it as an, and the preceding term for an is an minus 1. Okay, see here it is 3, and this is 3 minus 1, and here it is 2, this is 2 minus 1. In the same way, if I take n, so here you need to take an minus 1. Okay, next. So first term we are taking it as a. Okay, so here we are adding difference to the previous terms. Okay, so first term is a, second term a plus d, next third term a plus d, that is a plus 2d, like so on. So if you observe a plus d, see here a2 is equal to a plus 1d, a3 is equal to a plus 2d, that means this 2 is nothing but 3 minus 1d, and this 1 is nothing but 2 minus 1d. In the same way here 1 minus 1d will be there, so 1 minus 1 will become 0, so that's why a plus 0 is a. Okay, like that we can derive nth term formula. An is equal to a plus n minus 1 into d. Okay, so this is nth term of an AP.